In this video, we will learn how to factor polynomials. Poly means many, many terms. So if we have 2 terms, we call that a binomial. If we're factoring 3 terms, we call that a trinomial. If we're factoring 4 terms, we just say we're factoring 4 terms. Now, what does factoring means? Factoring means when they give you a polynomial, you try to simplify it to be able to solve it. So when I look at 3x plus 6, which is simple enough, but if I want to factor this, I can consider the GCF, or what's common between the 3x and the 6, and I can see that 3 is in common. So I factor the 3 out. So I try to think 3 times what would give me 3x, and that's an x, and then positive, so I copy down the plus, and then 3 times what would give me 6, and that's a 2. In this case, I have factored 3x plus 6. So 3 is considered one factor, x plus 2 is considered another factor. Now let's move on to the focus of our lesson, which is factoring out the GCF. Now, no matter what type of polynomial they give you, you always have to check for the GCF. Whether it's a binomial, a trinomial, or 4 terms, you always have to check. Is there a GCF I need to factor out? So let's highlight this part. Now, let's look at the example over here. 2n to the power 3 minus 20n squared. Now, some of you are really good with numbers, and you can find out that there's maybe an n in common. You can also look at the numbers and you can see that they are even numbers. So you can directly jump into this step and figure out what the GCF is. However, if you're having trouble finding out the GCF, what you can do is you can simplify it for yourself and find out the different factors that 2n to the power 3 is made up of, what the 20n squared is made up of, and then see what's in common between them. So let's go ahead and break it down. And I will do the same thing with number 1 and 2. I will break it down into the different factors. And hopefully by the time we get to number 3, we will be able to find the GCF right away. Okay, so now let's start with the 2n to the power 3. 2n to the power 3 means the factors are 2, n, and another n. I copy down the minus, and then 20n to the power 2. Now let's look at the 20. 20 means 4 times 5. 4 can also be written as 2 times 2 times 5, which is a 20. So you have to break it down into the prime numbers. The n to the power 2 is n times n. Now, after you break it down into the different factors, we have to find what's in common, and that would be my GCF. Now, I can see that there is a 2 in common, so that's going to be part of my GCF. I can also see that there is an n in common, so let's cross it out. I can see that there's a second n in common, and that will be another one in my GCF. Now there's an extra n, but there's no n on the other side. On this side, I have a 2 and a 5, but I don't have any more 2s or 5 on the first term. So then my GCF is just this, 2 times n times n. So n times n is an n square, so my GCF is 2n to the power 2. Now, if I want to factor this, the GCF does not just disappear, so I always place my GCF in front of the parentheses. Now I have to look back and see what's left of each term. I can see that the 2, the n, and the n got cancelled out because they are part of the GCF. What's left is the n, so I copy down the n. I also copy down the minus, and then I look at the second term and ask myself what's left, what's not crossed out, what's not part of the GCF. And that's the 2 times the 5, and that's a 10. So that's going to be my factored term. 2n to the power 2 is my first factor, and n minus 10 is going to be my second factor. Now, how can I check my work? I can always distribute to check if I factored correctly. So 2n to the power 2 times n is 2n to the power 3. There's the minus, and then 2n to the power 2 times 10 is 20n squared. So I factored correctly. Now let's move on to our first example. Now, in number 1, we have 2vm to the power 2 minus 14vm. Now again, you can directly find the GCF if you're good with that, or you can break it down into the different factors. Now 2 is just a 2, v is just a v, m to the power 2 is an m times and another m, minus 14 is basically 2 times 7, the v is just a v, and the m is just an m. Now to find out what the GCF is, I have to cross out the common, and that would be part of my GCF. So I can see that there's a 2 in common. I can see that there is a v in common. I can also see that there is an m in common. So then 2vm is my GCF. But remember, it doesn't just go away. It's going to be in front of my parentheses. Now let's look at the first term. What's left? The m is left. So that's going to be what's left over, and it's going to be in the parentheses. I copy down the sign, which is a minus in this case. And then if I look at the second term, what's left is the 7. So then m minus 7 will be my second factor. Now to check my work, I can always distribute. 2vm times m, that's 2vm to the power 2. 2vm minus 7, if you multiply them, you get negative 14, because 2 times 7 is a 14. And you just copy down the vm since the 7 has no v or m, so you just copy it as it is. Now let's move on to number 2. And we're going to still break it down into different factors. So if I look at 5b to the power 2, that's a 5 times b times another b, plus 45 is basically 5 times 9. So 5 times 9 times b. Now let's figure out what's in common. I see 5b in common, so that's going to be my GCF. Now my second factor is going to be b plus 9. And there you go. This is my factored form. Now I would like you to pause the video and try number 3 and 4 on your own. Now I hope you tried on your own, and let's try to figure out what the GCF is for number 3 and try to factor it. Now let's look at the numbers first. This is an even number 4, and that's an even number 2. So 2 is in common. Now what will be left? So 4 divided by 2 is what? It's a 2. And if you want to double check, 2 times 2, that's a 4. So then 2 is going to be my first GCF. Now if I factor 2, let's copy down the minus. Now 2 times what would give me a 2? That's a 1. So first of all, I thought about the number, okay? Now let's look at the first variable, which is the k. I have a k over here and I have a k over there. So k is in common, so then the GCF is a k. And now it's 2k. Now, if I take a k out of this term, there's no k left, so I don't have to write a k on the inside of the parentheses. And if I take a k out of this term, it's going to be gone. So there's no k in this side of the parentheses as well. Now let's move on to the x. I have an x to the power 2, and that means it's an x and another x. And there's an x over here, so that's just one x. So then there's only one x in common. Now, x to the power, what would give me x to the power 2? If I multiply x by x, that will give me x to the power 2. Now, let's move on to the second term. If I factored out this x, what will be left? Nothing, because I factored it out. So then, in this case, that's going to be my factored form. Let's double check. 2kx times 2x. So 2 times 2, that's a 4. K, so that's a k. X times x, that's an x squared. Minus. And then 2kx times 1 is itself. So 2kx. And that's a common mistake that students do. They see then, since I factored out the 2kx, then nothing is left. And they write the factor as 2kx parentheses 2x. And they don't put the -1, thinking that if they factored out the 2kx, nothing is going to be left over here, so I don't have to write anything over here. This is what they think. But let's say that this is your answer. Distribute to check your work. So let's check. 2 times 2, that's a 4. K, so that's a k. X times x and x squared. Okay, where's the second term? It's gone. So then this factored form is incorrect. So if you factor something out completely, make sure that you have a 1 over here to represent it once you distribute. Okay? Now let's move on to number 4. Now that's a trinomial, but it's the same concept. Every time I have any type of polynomial, the first thing I should ask myself, is there a GCF? So we start by looking at the numbers. 6, 12, and 4. 6 is basically 3 times 2. This is what should go in your head. You don't have to write it down. 12 is 2 times 4. 4 is 2 times 2. Now remember, when you take the GCF, it should be common between all 3 terms. Not just 2 terms, it has to be common between all 3 of them. So 2 is in common. Okay? Now, so what's going to be left of the 6 is 3. Don't forget to copy the minus, this minus over here. Now, in the second term, there will be a 4 left. Now, if you factor out a 2, one of the 2's, so 1, 2 will be left, so plus 2. So you can take it slowly. You can think of the numbers first, and then you can think of the variables. Now, let's look at the x's. I have an x to the power 4, x to the power 3, x to the power 2. So x to the power 4 means I have 4 x's. X to the power 3 means I have 3 of them. X to the power 2, it means I have an x and another x. So let's see what's in common. So x times x is in common, and that's an x squared. So what's going to be left of the first term if I factor out x and another x? So x to the power 2 will be left. And then of this term, well, how many x's will be left? Only 1. And this one, I took everything out, so there's no x left. So that would be my factored form. Now, for it to be easier, always think that if it's x to the power 4, x to the power 3, and x to the power 2, always the one with the lowest power is going to be the one factored out, because it will be used completely. Now the others, if you just 3 minus the 2 x's that you took out, only 1 will be left, and 4 minus the 2 x's that you took out, so only x to the power 2 will be left. So that would be my factored form. Always remember to distribute to check your work. Now let's move on to number 5. And number 5, we have 4 terms. So if you feel more comfortable writing down all the factors, go ahead, by all means do that. But I'm going to take it one thing at a time, which is the numbers at first. So 3, 9, 15, and 6. What is in common? All of them are divisible by 3, so 3 is in common. Okay? Now, let's look at the A's. So that's an A cube, A4. Remember what we said? The one with the lowest power, which is the A, because A means A to the power 1, because there will only be one A. So A is in common. Now let's move on to the B. B squared, B, and B5. Again, the lowest one. So the lowest power is just B. So then B is in common. So 3AB is my GCF. Now let's think of my second term. What's left? So if I take 3AB out of this, so I took the 3 out, I took the A out, and this is B2, it means there are 2 of them. And I took 1 out. I took one of the B's out. So what's left? Only 1B minus. Let's move on to the second term. 9. 9 divided by 3 is a 3, or you can think 3 times what is 9, and that's a 3. A cubed means A times A times A. I took one of the A's out. So how many A's are left? A squared. B means there's only one B, and I took it out. So there's no more B for the second term over here. Now let's move on to the third term, so plus. 6 is 3 times 2. I factored out the 3, this one over here. So what's left is the 2. Now let's think of the A's. A means A times A times A. 4 of them. I took one of them out. So how many A's are left? A to the power 3. B5 means there are 5 of the B's. I took one out, so how many are left? 4 of them. So B to the power 4. So that would be my factored form. Now let's move on to the second focus of our lesson, which is difference of two squares. That applies if you have a binomial, where the first one is a perfect square, the second term is also a perfect square, and there's a minus between them. In this case, you can simply factor it as A minus B into A plus B. Okay? Now, let's move on to our first example. To check if you can apply the rule of difference of two squares, you need to check if it works. If the first one is a perfect square, then you're on the right track. So let's look at the first one. 4 times 4 is 16. X times x is x to the power 2. So 16x to the power 2 is a perfect square. And that is for x to the power 2. Now let's move on to number 9, or the number 9. The second term. 9 is 3 to the power 2. So that is also a perfect square. It's 3 to the power 2. And there's a minus between them, so there you go, that's the difference of the two squares. Then I can apply the rule, which is A minus B and A plus B, where A is the first term, minus B, which is the second term, and then A, which is the first term, plus B, which is the second term. And there you go, that's my factored form. Very simple and easy. Now, why does this work? Let's distribute or FOIL to see why this works. 4x times 4x, that's a 16x to the power 2. 4x times 3, that's 12x. Negative 3 times 4, that's negative 12x. And negative 3 times 3, that's a negative 9. So do you see how the middle terms cancel out? Because one of them is a negative and the other is a positive. So you're only left with the binomial 16x squared minus 9, and that's why this works. Now let's go ahead and move on to our first example. And let's check if 16x squared is a perfect square. Now, the moment I see a minus between two different terms, I directly think of difference of two squares. Now, if this applies, whether this applies or not, I have to check if each term is a perfect square. So what can I multiply by itself to get 16x to the power 2? That's 4x, because 4 squared is 16, and x squared is x squared. Minus the second term. So is the second term a perfect square as well? I know that 5 times 5 is 25. I know that y squared times y squared is y to the power 4, so that is a perfect square. Because y4, every time you have an even power, that means you can actually write it as a square of something. So we have 4 of the y's. So that is y squared to the power 2, because look, there are 2 of them. Okay? So every time you have an even power, whatever it is, you can always write it as a square of something. Now, because it's difference of 2 squared, I can directly apply the rule 4x minus 5y squared. That would be my first factor. And 4x plus 5y squared. And that would be my second factor. Now, I would like you to pause the video and try number 2, 3, and 4 on your own. Now I do hope you tried, and now let's see if we can apply the rule of difference of two squares. I do have a minus, so I'm on the right track. I might be able to apply the difference of two squares, so I need to check if it's made up of perfect squares. Now 4 can be written as 2 squared. 49x to the power 2, I know that 7 times 7 is a 49, so I can write it as 7x to the power 2. So there you go, that's the difference of the two squares. So I can factor it as 7x minus 2 and 7x plus 2. Now remember to double check your work. You can always FOIL. And if you get that, then you are on the right track. That is correct. Now let's move on to number 3. Now I see a plus over here, so I cannot apply the rule of difference of two squares. I should have a minus over there. I should have a difference. So the second thing I might think of if I have a binomial, like two terms like this one, is there a GCF? Can I factor it using the GCF? There's nothing common between x to the power 2 and 81, so I cannot factor it further. So we call this a prime because we can't factor it. Just like when I ask you like about the number 2, like what are the factors of 2? 2 does not have a factor because it's a prime number. Let's say 3. Can I factor 3? No, there are no factors of 3 other than 3 and 1, which is itself, so it's a prime number. What about 6? Yes, I can factor 6. So the different factors of 6 are 2 and 3. Okay, 6 and 1, but it's like the number in itself. So it's factorable. So if something is not factorable, it means it's a prime number. And in this case, it's a prime polynomial. Okay, let's move on to number 4. Now, in order to decide whether this is factorable or not, I need to think of the difference first. So do I have a minus between them? Yes, there's a minus. Now, is this a square of something? It looks like it. 10 to the power 2 is 100. A is A times A. I have an even power, so yes, that's fine. I have an even power. It means, yes, I can write it as a square of something. Oh, I have an odd power. Then that is not a square of something. Because, like, C cubed is like 3 of the C's. And I can't square it. Like, if it is like 4, then I can write this as c squared to the power 2. If I had c to the power 6, then I can write it as c cubed, because there's 1, 2, 3 to the power 2. Because like in each box there are 2 c's. So every time you have an even power, I can actually group them as squares. But c cubed, I cannot group it as a square, so then I cannot use the rule of difference of 2 squared. So my second thing is that, is there a GCF? There's nothing in common between those two. So again, this is a prime polynomial. Now let's move on to number 5. Now p, I have a difference, so I have to think of the difference of 2 squared. P squared is like p to the power 2 minus 1. 1 to the power 2 is 1. So yes, it is difference of 2 squared, and then the two factors would be p minus 1 and p plus 1. Now I hope this video was helpful. Make sure that you work on the practice sheet to practice factoring. The second video will be presenting factoring trinomials in different methods.